What's going on, everybody? Today we're going to be going over the properties of water. The first thing, there's 8 of these today, that you need to know is water's density. Water is less dense as a solid. Now, this might not make sense, but this is actually like a good way to think about this is like you wonder why ice cubes float. They're both made of H2O, and ice is a solid, so you think it would sink, but it doesn't. And this is perfectly showing that water is less dense as a solid. Water is a great solvent, and this is referring to the water solubility. If you don't know a lot about chemistry, you might not know the words solvent, solute, or solution. Just know that solute is the substance being dissolved, solvent is the substance being dissolved into, and combine it together and you get a solution. Water is actually known as the universal solvent in biology, and I would assume chemistry too, science in general. Solubility here, it's like, just think about it. Think about how many things can go into water. You can put salt, a polar, believe salt is polar, NaCl, polar. Like substances, polarity will dissolve in each other. So if it's a polar molecule and another polar molecule, it's going to dissolve. If it's a non-polar and a polar, it won't dissolve. Any way you can combine it, same polarities will dissolve in each other. Water has a high heat capacity. What does this mean? Well, think about it. Have you ever been on the beach? If you go on the sand, you're going to notice it's very, very hot. That has a low heat capacity. There's a lot of heat being built up in that sand. But you step into the water, it's nice, refreshing, and cold. And this is because water has a very, very, very high heat capacity and is going to be able to hold a lot of heat without actually heating up that much. So think about your bodies of water. You know, your fish don't want to be boiled alive. So that's literally why we have big oceans, because it will absorb the heat and it won't kill the fish because, it won't get too hot in there. Water evaporative cooling. Now, just think about this. Evaporating, water going into gas form, going bye-bye. Cooling is going to take heat away. So when water evaporates, it will take heat with it. So a good way to think about this is, think about when you sweat. You sweat and water comes off your skin, and it's actually going to leave and evaporate off your skin, and it's going to take heat with it. This is a way that your body keeps homeostasis. And if you don't know what homeostasis means, I highly suggest you look at my video on that or another video. I bet people will explain it way better than I. I'm just doing a screencast, so. Water cohesion and adhesion. Cohesion is the attraction to the same molecule. Adhesion is the attraction to a different molecule with the same polarity, I should say. So we have H2O here in this little diagram. Cohesion, they're attracted to each other. They're going to bond easily. Adhesion, they're going to attract to other molecules. We also have surface tension. This is a result of cohesion. Remember, cohesion is the attraction to each other. They're going to be really attracted to each other to the point where it makes a very strong layer on the surface that won't let things sink. And if you've ever done this, you'll know that the paper clip is very dense. It's metal, straight metal, aluminum, right? I think. And water's just water. It's a liquid. And you would think that the paper clip would sink, but it doesn't because of surface tension, that cohesion between the H2O molecules. Lastly, we have capillary action. This is a result of cohesion and adhesion. This is something that might be a little difficult to understand, but hear me out. So here in this diagram, we have a big thing of water, and then we have a bunch of tubes. We have the small tube, or we have this really thin tube, this medium thickness tube, you could say, and then this really wide tube. And what's going on here is cohesion is bringing the molecules together with attraction, and adhesion is attracting them to the sides of the glass here. So, and the thinner the tube, the more strong the capillary action. So think about your plants, when they are using roots. Roots use capillary action to bring the water up. It's these very thin tubes, and that capillary action is so strong that it will be able to bring the water up to the plant where it's going to use it in photosynthesis. Well, that's going to be the end of this one, guys. Hope you guys did learn something. If you did, please drop a like. Maybe subscribe if you learned something. Drop a comment if you have any criticism. If you do, I will not be offended, I promise. Anyways, guys, have a good one. Bye-bye.